Okay. Uh, we present about our project hydraulic. First, I want to say thanks to our lecturer, Encik Wan Afni Zambil Wan Muhammad, for teaching us for hydraulic subject, code BFC21103. Okay, next. Okay, this is our group member. First, my name is Muhammad Saiful Abdul Latif. My matric number is CF220230. Okay, then Azizul CF220152, and then Adik Saudin CF220201. Then Muhammad Amal Fahmi Muhammad Siti CF220212, and lastly is Raja Ahmad Faiz bin Raja Ahmad Fauzi CF220149. Okay, next. For introduction, a network of pipe transport stormwater to pond, lake, stream, and river, subterranean pipe, channel, and structure. The network contain both public and private system. It is essential part of the country management system. Storm runoff, composition, timing, and dispersion. And number three is the underground drainage system, known as stormwater drainage system. Collect stormwater that overflow onto a road or other hard surface, owing to impermeable pavement or other hard surface, and is not absorbed by the earth. Lastly, is stormwater drain are constantly being flowed by water from hard surface like driveway, uh, parking lot, roof, and highway. Okay, then next. Okay. This is our study area, which is at the Taman University Parit Raja Batu Pahat. You see, as you can see, the catchment area is polygon, and for the we take from we take from the BHP Petro until um, to Taman University, and then from Taman University uh, uh, route to RC Grant. Okay, from BHP to Taman University, the length for the drain is approximately is 689 meter, and the depth for the drain is 1.8 meter, and average watt for the drain is 5.4 meter. Okay, next. Usually as a opportunity the system is often independent system. It is connected to our tiny drain. Okay, as you can see on continuation from the uh, main drain, we have a smaller drain to connect to maintain the flow of the water. Uh, in, which called by uh, it, it also called by intersected drain, and which supply a sizable portion to the this range connect the range the channel has the channel shape and okay now because similar flow a lot of people happen is to establish the best type and size of drive system for the Taman University Paya Raja drainage system. Lastly is
Okay, for the problem statement, we have two problem statements. Number one, size of the flow channel not suitable for the area and need to be analyzed, especially in the design the storm drainage system. Number two, the drainage system was not designed properly to mitigate the flood and heavy from over the road. So this is the photo, flash flood at Taman University. So for the methodology, in this group, the task that being given to us is to complete the drainage design manual of part of the Taman University Parit Raja. To propose a suitable drainage design perfectly, a suitable analysis method was used to design the area, climate, and condition. Through the information that has been given to us, the area was prone to inundation due to flash flood which occur during the short and instant fall. So for the area of catchment, to get the detailed information about the research catchment area, our team member went to the area and collect the data by using the Pro to get all the information that will be useful for the determine the suitable for the drainage. The area of catchment was also calculated by using the same website to get the area and dimension of the desired area. The total area of water is 34,1324 millimeter square, which equal to 34.1324 hectare. The rational method was used to properly calculate the data analyzed. The Urban Stormwater Management Manual for Malaysia was used to verify peak discharge for the area in m meter cube per second.
Okay, so next, this is the meaning proudness. To start the calculation, we need to get the data from the table at the site survey. Our team conclude that the area was grass drained with long grass cover more than 150 millimeter. The mean roughness N is 0.050. The second table was taken from table 2.3, which is the tail grass cover 0.050. Okay, so this this is a dimension and area of drainage.
Okay, that's all for me. Thank you.
Okay, so next the friction slope, which is using the friction slope equation. This friction was calculated, and as a result, the value of friction slope was 0.00289. The equation was using highest value elevation, which was 10, and lowest value elevation was 8. The length of channel also required to calculate using the calculation. Okay, so the formula is S something S equal to highest value elevation minus lowest value elevation over length of channel. Okay, next for the empirical IGF curve. The the needed data was collected in the area in Johor and the station near sector JPS Batu Pahat. So the area data, we can get the constant value of the area, which is lambda is 64.099, K is 0.174, theta is 0.201, and N is 0.826. So this the table was taken, which is number 6, which is a sector JPS Batu Pahat. In addition, the study area can be categorized into commercial and business with a minimum RE per year was 100 years. So we assume T equal to 100. Okay, next for the table 2.5.2, which is a quantity design storm. We use a commercial and business center. So for the minor system is 10 and the major system was 100. Lastly, to calculate the runoff coefficient and peak flow, we need to refer to the table 2.6. The type of land use of the area need to be chosen. The area's land use was commercial and business center with a runoff coefficient higher than 10 years, was 0.95. This value will be inserted in calculation as C. Okay, so for the peak flow, we use a commercial and business center, which is a for minor system 0.90 and for the major system 0.95. Okay, so the formula is Q equal to C, I and A equal to 360. After the last step of the rational method to find peak flow, Q, we need to find the Q assumption for the new design of drainage. The remaining equation was used to calculate the Q assumption. Area, weighted perimeter, and the slope were calculated before we use the remaining coefficient. Then we process to calculate the Q assumption. Okay, so
Okay, now we going through for the result and the analysis. The referring to the picture below, the survey in the study area was conducted to obtain some important information by using the Google Earth Pro. The inspection were also made to study the direction of the flow of the drainage water and the causes of the flash flood in this area. Okay, next. Okay, this is the data from the Google Earth Pro. So this from the left one is the first cross section of the channel, and the second one is the second flow of the channel. This data we can get the high elevation and lowest elevation from the channel, and also the length of the channel. Okay, next. Okay, so here we do the calculation to find the flow rate of the channel. First, we identify the data, which B equal to bottom wide, Y equal to depth of the water, and T for the top wide. Okay, next. For the first cross section, first we calculate the hydraulic radius by find the value of area divided by weighted perimeter. After that, we find the friction slope for the channel, and we get 0.00289. After that, we find the D in the unit hour by using this formula. And then we calculate the I using the formula given in the methodology, that we get 325.45 millimeter per hour. Then we get the flow rate by using the formula Q equal to C multiply A multiply I divided by 360. Then we get 19.54 meter cube per second. Okay, we going through for the second cross section. Okay, for the second cross section, it has a shape of a rectangular. So we use the formula B multiplied by Y, and then we find the headed radius using area divided by weighted perimeter, and then we get the radius of 0.164 meter. And then using the fraction slope, insert the data and we get 0.0102. And then using the formula to determine the D, and then we get 0.18 hour. After that, we use the determine the I value by using this formula, and then we get 316.96 millimeter per hour. After obtain this all the information, then we insert this information into this calculation, and then we get 9.51 meter cube per second for the flow rate of the cross section 2.
For the proposed new design of channel section, based on the calculation from table cross section 1 and cross section 2, the obtained data has been calculated and analysis that the one factor that involve flash flood in Taman University Parit Raja is the area of the cross section of drain that is small and not suitable. Therefore, the way to prevent flash flood from occurring is to enlarge the size of the drain to let water flow smoothly during rainy day. So it can raise the flow of water more than peak flow, which is 29.75 meter cube for cross section 1 and cross section 2 for 28.55 meter cube. For the cross section calculation, we use area A equal by plus z y square. We got 12.6 meter square. For the z, we use 3 over 3 z equal 1.2 over 3. We get 0.4 weighted perimeter. P equal b plus 2y. I divide 1 plus z2. We got 9.46 meter. Hydraulic radius, we use R equal 12.6 over 9.46. We got 1.332 meter. For the equation, S equal highest value elevation minus lowest value elevation over length of channel. We got 0.00289. And for the table 2.1, we use ED equal N L over R 2 over 3 and S 1 over 2. We got 8.87 minutes. For the equation 2.2, we use I equal lambda TK over D plus theta N. And we got 340.94. And the equation 2.3, we use Q equals C I and A over 360, and we got 20.47. And the output for table output for table R equal 1.332 meter. Equation S equal 0.00289, table 2.1. TD 8. TD equal 8.87 minute. D is 8.87 over 60, and we got D 0.1478 hour. Equation 2.2, I equal 340.94 millimeter per hour, and Q peak equal 20.47 meter cube per second. For the cross section 2, we use the table area A equal BY. We got 1.67 meter square. Weighted perimeter P equal B plus 2Y. We got 3.98 meter. Hydraulic radius R equal 1.67 over 398. We got 0.42 meter. For equation, we use S equal highest value elevation and highest value elevation minus lowest value elevation over length of channel. We got 0.0102. For the table 2.1, TD equal NL over R 2 over 3 and S 1 over 2. And we got 5.78 minutes. Equation 2.2, I equal lambda TK over D plus theta N, and we got 389.36. And equation 2.3, Q equal C I and A over 360 and equal 11.69. For the output table, R equal 0.42 meter. Output equation S equal 0.0102. Table 2.1, TD equal 5.78 minute, and D is 5.78 equal 60, and we got 0.096 hour. Equation 2.2, I equal 389.36 millimeter per hour, and equation 2.3, Q peak equal 11.69 meter cube per second. For the discussion, after settle the calculation from the table, that has been obtained, we notice the flow design of discharge is higher than flow peak discharge. The calculation is include both sections to get the satisfied result. The result for this project get passed successfully because the flow rate for new design is higher and more efficient than the old. This is our table that we got for cross section 1 and cross section 2 area, depth, hydraulic radius, and flow rate. So the design is fast and suitable for the use construction to prevent flash flood to happen at the area of the Taman University Parit Raja. The first method that we use to measure the dimension of the drain by using tape measurement, but we noticed that the soil strength nearby that drain was too weak and can be dangerous to us. The erosion of the soil also could happen with the soil that have low bearing capacity. For the safety reason, it was good to measure the dimension by using Google Earth Pro. For the conclusion, in summary, infrastructure such that environmental effect will be minimal. One of the fundamental responsibility of the design and engineering team is to make sure that there are no drainage problem on the job site, particularly with regard to how structural work will be impacted by uncoordinated weather or other conditions that could result in flooding from out of date drainage. In the case of the project, flooding was frequent occurrence, particularly during the monsoon season. The drainage system at the project site is undersized and overly shallow, which caused the water to flow erratically, especially during the rainy season. During the rainy season, when an excessive amount of rain is created, therefore, in this subject, hydrology and hydraulic analysis is, is the area that receives the most attention. Here we study about meaning roughness, friction slope, intensity duration frequency, IDF, land usage type, and average recurrence interval, ARI, to calculate the drainage peak discharge as well as the suggest peak flow design for the on-site drainage. The main cause of the flooding problem at the roadside drain of Taman University Parit Raja is verified based on the calculation by using the rational method and the Manning equation, which has been taught in the course of hydrology and hydraulic, show that the capacity of the roadside drainage along Taman University Parit Raja, Batu Pahat, Johor is insufficient if the rainfall happen with the high intensity. That's all for our presentation. Thank you.
Thank you.